What if I told you students could actually understand physics better without ever needing to step into a real laboratory? In our last video, we asked a particular question that can virtual labs replace real physics labs? We looked at some of the advantages of physical labs over virtual labs. But today we are flipping the question and we are going to be looking at what research actually says about virtual labs. And in the sense that we are going to be looking at this from 5 proven benefits of virtual labs in physics and why schools are starting to take them more and more seriously over the years. Of course, we are going to be looking at why we think, according to research, why students learn physics better without a real lab, and of course, what the research actually says. Firstly, we're looking at it from the angle of conceptual understanding. Do virtual labs actually improve students' conceptual understanding? The answer is yes. Because of virtual labs, students can see physics in action, they can get instant feedback, and they can learn by doing. What am I talking about? You see, one of the biggest problems students have in physics is not even calculations. It's understanding what's actually going on in the classroom when these concepts, these theories and laws are being explained to them or introduced to them. Virtual labs actually change the way these students get introduced to these concepts, theories, laws, and so on and so forth. Because instead of memorizing formulas, students can actually manipulate these variables and instantly see how these things actually change and affect their day-to-day lives. For example, imagine adjusting voltage and immediately seeing the results, seeing how current actually responds. No waiting, there's no confusion. So the student, of course, is intrigued, and that increases his motivation. And then aside from that, that kind of reaction that the student gets, that feedback, that instant feedback that we're talking about here, is what sort of helps to accelerate or improve the speed of learning. Think of it like, let's say an example of like you're using a flight simulation to explain a principle in physics. Let's say you're trying to teach students how let's say a plane moves, and we are just using verbal explanations, and we are using a picture of a plane as an instructional material. Even though the student can see what you are trying to visualize with your words, the student may or may not fully understand how this really affects his life, especially for a student that has never ever left the confines of his village. He more or less is just going to just learn that, and then he just stays in the classroom for that day, or more or less he just reads to memorize, and then that's it. There's really no real life application. But with virtual labs, they help to like present the concept or the theory to the students in a much more interactive way. In the real world, let's say for instance, we cannot see sound waves or Doppler effect, but of course, even though we cannot see them with our naked eyes, virtual labs act like a pair of X-rays, and they allow us to like visualize these invisible forces in a way that it doesn't even need to it doesn't need to have any risk to the students, in the sense that when we talk about X-rays and all of that, we talk about the health implications, like how it could affect the eyes and all of that. But then with virtual labs, it's something that they interact with, like they can see and they can do. So it's not just the seeing itself, it's also the doing as well. So virtual labs help to like explain these concepts better. Moving on, we're also going to look at the implication in terms of risk. Like we said earlier, virtual labs take away a lot of the danger that comes with real physics labs. Let's be honest, things like broken laboratory equipment, electrical hazards, limited materials. These are some of the challenges that normally the average physics lab in a country, let's say in a developing country, would face. And virtual labs sort of remove all of that, all of those limitations. Students can experiment freely, make mistakes, and try again without fear of like damaging equipment or like hurting themselves or even burning themselves out trying to keep up with time, because now it becomes individualized, and then a student can learn at his own pace. And in learning, that freedom to actually fail, to like keep trying and trying on your own, and then before you eventually get it, is a very powerful tool. It's like practicing driving in a realistic video game before actually going onto the main road, and then you can, in a video game like that, you can crash as many times as possible, as long as you're actually learning from those mistakes, and then it does no harm to the person who is actually playing such a game. Research also shows that students can actually even experiment with high risk scenarios, like mixing let's say sodium and water to see an explosion, or handling or like a nuclear fission or fusion experiment, without any danger at all to the student or the classroom. And then in learning, like we earlier said, that freedom to actually fail without a feeling that any small mistake you could end up in hospital, that that helps to like make the learning much more pleasant for the learner. Next we'll be looking at is if virtual labs can or are actually accessible to all, in terms of can every school actually use virtual labs, or is it limited to some schools? So we can already establish that not every school has a fully equipped physics lab. Some environments have the privilege of having standard physics labs that can run virtually any experiment, but some environments, like contexts where they can barely even get constant electricity, constant water, and other amenities, basic amenities. So in context like this, students learn physics without ever really doing actual experiments. Most of it is like what they call alternative to practical. So, but virtual labs can actually change that. All you just need is a computer or even a smartphone, depending on what virtual lab you are using, and suddenly students can perform these experiments that would, in a different scenario, be impossible. And this is important for, like, we already established, underdeveloped and underrepresented or under-resourced schools. Whether a student is in a modern city or in a village, this virtual lab is very much accessible to them, and basically it is not just limited to even being used in the school. It can be used for also distance learning, like remote learning and the likes. And it can be done, like we earlier said, either on the phone or using a laptop. More so, they can actually measure the gravitational force, for instance, on, let's say, Jupiter or Mars, from their desk. As in, they don't necessarily need to go all the way to um, let's say, Elon Musk's company, or a company that deals with space travels, before they can learn about how Kepler's effect and so on, Kepler's laws and other gravitational laws actually work. So next we'll be looking at is, do virtual labs actually make learning of physics more engaging and interactive? Of course, we have already touched a little bit about this already, but let's face it, traditional labs can sort of enhance physics learning in ways that learning doesn't become rigid or boring. Like we have earlier talked about games and simulations. Traditional labs tend to just make learning really um, they make them really rigid, in the sense that they're hardly flexible. The teacher just has to stick to this particular routine, like a recipe book that where you just follow steps just to get results, and then that can get really tiring for both student and teacher. But virtual labs are much more interactive. They are explorative, and they just embody everything that has to do with fun learning. And virtual labs are more like open world games. Students aren't just following instructions or copying notes or looking at a picture and trying to figure out a meaning for themselves. It's like the opposite of that. They are instead of observers, they are participants. They are involved in the learning process. They are developing, they are building, they are manipulating variables directly, and they don't necessarily have to do it using a particular way. Let's say, oh, this is the way we use. This is the way we. Let's say for instance, we are talking about let's say we want to test an idea of whether or not a roller coaster, for instance, uses a particular principle to work, and then throughout the entire lesson you're just using word of mouth to explain this particular principle to the students. It gets to the point that the students become bored, because they're seeing the picture of a roller coaster either on the board or using a flowchart or whatever it is, but they are not actually they cannot even see the roller coaster moving, so they don't even know per se what you mean by what principle makes it move. Also, of course, there are some students that may have had experience with what a roller coaster is, but majority don't. So, but by using virtual labs to teach a concept like that, you expose the learner to what is called experiential learning. They don't just at that point now get to just listen to your notes and take your word for it. Now they can test that idea by having a visual representation of that concept in front of them. They can click, they can drag, they can manipulate. They can they can test hypotheses instantly, discover unrelated and related relationships through all of that play and learn. And then the virtual lab interfaces are right now still one of the best kinds of learning simulations ever built, because aside from um, the beautiful user interface, the use of colors, shapes, and all the likes, it's also easy to use depending on whichever one you are using in your classroom. And this interactive game-based approach naturally boosts curiosity, motivation. It makes the lesson or the subject less boring and feels more like an adventure at this point. And that level of interaction actually increases, like I've already said, curiosity and engagement. Lastly, we'll be looking at one more benefit, which is cost effective. Is virtual labs or are virtual labs cost effective? Setting up and maintaining a physical lab on its own is very expensive, and especially when you're talking about a very standard physical lab, if it's very standard physics lab, it costs so much to get, for instance, a delicate vernier caliper or even highly quality glasswares, things like, not even talking about things like retort stands, the tables, the taps, running taps with water, and so on and so forth. All these things cost a lot compared to virtual labs. Um, Virtual labs help to take away a lot of the challenges that can affect physics, real physics labs. For instance, in virtual labs, you don't need to care, or you don't need to worry about breaking an equipment and then having to want to replace it or upgrade it. In virtual labs, you also do not need to worry about whether or not an equipment in the laboratory is not enough. With virtual labs, you can be rest assured that it contains everything needed, and then all you just need maybe from time to time is to provide, depending on the number of students you have, provide much more technology, maybe smartphones or laptops or computers for your students. Now, as we have already said, virtual labs are immune to like wear and tear in the sense that you don't necessarily need to worry about the equipment getting rusted or getting broken or getting lost or getting out of date and you need to upgrade them. So, schools that want to improve the standard of learning physics in their school should actually consider using virtual labs, because it takes away all of these challenges with very little cost. Now we have virtual labs that are even free to use. You can download any of the apps or softwares on your PC and then just load it for the students. Of course, you teach the teacher if the teacher is not accustomed to using that kind of a thing to teach. So the teacher, of course, has to practice before coming to the class to use such software in teaching the students. So lastly, schools that want to actually use virtual labs in teaching physics in the classroom also have to remember that, just like we have been saying from the very beginning, virtual labs are not a replacement for physics labs. Rather, they should be used side by side with real physics labs. Now, why do I say this? The reason, of course, I say this is because virtual labs are not perfect. Research already shows that even though they have all of these benefits and much more, there are still some things that, virtual labs cannot replicate. One of which is hands-on skills. The direct physical touch that feel that students get when they actually touch this equipment, virtual labs cannot give them that. So it should be used side by side with real physics labs. Only in cases where a real physics lab is not even available is when virtual labs can be used as the first option. And of course, again, another reality check is the fact that virtual labs really do not basically contain the tactile feel or that tactile. They do not give students that tactile experience that comes with real physics labs. I remember when I was in school, I think one of the very first things that we loved about science generally was that when it was time for physics, we know that if we were doing physics in our classrooms, it was just boring. It doesn't matter if the concept was interesting or not, but it was just boring because we were in the classroom, meaning that we spent all the day in the classroom. So any chance at all to get out of it was like a good feeling, a relief for us. So virtual labs, on the other hand, even though they take the students out of the classroom, they still do not technically take the students out of the classroom. So, but in real physics labs, students can get out of the classroom. They can, that motion from here to there also helps to like improve their mental health and then prepares them for what it is they're about to do in the lab. And all of these things just encompass what we are talking about, which is that virtual labs are not a standalone and they should not be used as a standalone. Rather, they should be used to augment or complement real physics labs. So, why virtual labs are powerful from everything we have established so far, the real question now becomes, what are we losing when we rely on them too much? In our next video, I'm hoping that we are going to break that down and discuss it better. Thank you so much for watching. If you haven't seen the last video I made, I'll attach a link above so you can watch it. Please like, share, subscribe, and I'll see you in the next video. Bye.